Okay, this is the pump house question from Hayes and Harris that was put on the homework help page, and we haven't been able to correct it in class. So I'm going to do it here in the video. You can watch the video on your own. So we're trying to find where to put a pump house at point X. You've got to get, the pipeline has to go from the pump house X to the house at A and the house at B. And we have to figure out the point so that we minimize the amount of, point X between M and N, so that we minimize the amount of pipeline used. Okay, now M and M are 5 kilometers apart. If you go up from the river here, this is 5 kilometers apart, M to N. But if you go from M, which is at the river base, to A, that's 2K, and from N to B, that's 1K. Okay, and so what we want to do is we want to minimize the length here. Well, the length of the pipe will be L1 plus L2. So let's call that L is L1 plus L2. Now that's going to depend upon where we put the actual point here, X. Okay, so if I call this side X, then I can call that side 5 minus X. You can do it the other way around too, but that's why I'm going to do it here. If I do that, then the length L1 by the Pythagorean theorem will be 2 squared plus X squared 1/2, right? This is the square root of 2 squared plus X squared. And L2 will be the square root of 1 squared plus 5 minus X squared. So it'll be 1 plus 5 minus X all squared, or this 1 squared, just so you can see where it's coming from, 1/2. So that's the expression for our length. What we have to do is minimize that. So we're going to take its derivative and set that equal to 0. And so dl dx, and it's a chain rule, so 1/2, call it 4 plus X squared to the minus 1/2 times 2X. And over here, we'll bring the 1/2 down. In the other expression, we have 1 plus 5 minus X squared to the minus 1/2. Now, when we go to differentiate the inside here of that square root, we've got the derivative of a 1, which is 0, and then the derivative of this expression here, which is another chain rule. Okay, so I'll write that 0 in so you can see where it's coming from. So it's 0, and then when we go to differentiate here, like we said, it's a chain rule. So that means the derivative is 2, 5 minus X to the 1 times negative 1. We want to set that equal to 0. Okay, so that's our derivative in our expression. Let's clean it up a bit. I can see here, it's red here. We can cross out a couple of those. And we can also cross out this 1/2 with that 2 there. Okay? And so that leaves us with X over the square root of 4 plus X squared. And then on the other side, we have a minus, because of this minus sign right there, 5 minus X all over the square root of 1 plus 5 minus X squared. And that's all equal to 0. Okay, so how to solve something like this? What we're going to do is we're going to bring this expression to the other side first. So that'll give us X over the square root of 4 plus X squared equals 5 minus X over the square root of 1 plus 5 minus X squared. Okay? Then we'll cross multiply and square both sides. Okay, so if I cross multiply first, I get something like that. And then here we get something like this. Okay, we're also going to square both sides. So that'll give us X squared, 1 plus 5 minus X squared. And over here we'll have a 5 minus X all squared times 4 plus X squared. So the square roots will make all the other expressions squared that don't have a square root sign on them. The squaring both sides, excuse me, will make any expression without a square root sign will become squared. And then the expressions with square root signs will lose those square root signs. Okay? Alrighty, so then now what we need to do is solve for x. We could multiply everything out. It's going to be a quartic equation. Seems like a lot of work. Maybe we can avoid multiplying everything out. Let's see. What if we just write this here as x squared plus x squared times 5 minus x squared. And over here, we'll write the other bracket as 5 minus x squared plus 4 times x squared times 5 minus x squared. Okay, so what we'll do is we're multiplying this times 4, that gives us this, and this times x squared, that gives us this other expression. And over here, we're just bringing the x squared through the brackets. I just want to try and avoid multiplying everything out because it's going to be a big mess. Now, having done that, looking carefully at this, I can see that these cross out. Huh. That makes things a little bit nicer. That leaves us with x squared is 4 times 5 minus x squared. And that is 25. This 5 minus x squared is 25 minus 10x plus x squared. So now, if we look at this equation, it's actually x squared 100 minus 40x plus 4x squared. Or 0 is 3x squared minus 40x plus 100. So now we're down to just a quadratic formula. Okay, so that means x is either it's 40 plus or minus the square root of 40 squared minus 4 times 3 times 100 all over 2 times 3. Okay? So second, well, I worked that out on my calculator here. So inside the square root sign, the discriminant is 400. So it was actually factorizable because that gives us 40 plus or minus 20 all over 6. So the answers are either 60 over 6, which is 10, or 20 over 6, which is 10/3. Okay, now if we go back to the question, you can see, well, x being 10 is right out of the question. I mean, x being 10 would mean we go, I don't know, put the pump house way over here, right? You know, that's going to be obviously some maximum distance. So it's 10/3, that makes more sense, and that's, what, 3 1/3, right? 10 divided by 3. So that's, well, kind of the way it looks like on the picture, really. 3 1/3 there, and then 1 2/3 over here, okay? So how far should m, they want us to know how far, to answer how far should m from point x be? Oh, okay, good thing we chose x to be that, mx, because that's actually the answer to the question. So the solution is that x is 10/3. So 10/3, and our units here, I believe, are kilometers. So point x should be 10/3 of a kilometer from m. Now notice I'm not checking for a max or a min. In these kind of questions, I mean, you can if you like. It's not a bad idea. It takes a lot of time though. And when it comes to testing, you know, examining, I mean, when you only test for the second order conditions if the question says something like justify that this is a minimum, or show by using the second derivative this is a minimum. Didn't say that, so we're going to stop the question there. Okay, there you go. That's that one.